Hi, I'm Chris Alexiak, a deep learning developer advocate at NVIDIA. Today, I'll be walking you through an example of making AI agents star performers using NVIDIA NeMo microservices. AI agents rely on tools to execute complex tasks effectively. As the number of available tools expand from 10 to hundreds, customizing the underlying models for tool calling becomes increasingly critical to maintain efficiency and accuracy. To continuously improve AI agents and better provide excellent user experience, organizations need to set up AI data flywheels, which are self-reinforcing feedback loops, as we see here, where the data from user interactions is captured and then used to refine AI models, leading to better outcomes and even more valuable data for further customization. Today, we're going to work through an end-to-end example demonstrating how to customize AI agents for precise function calling using the XLAM dataset. In this tutorial, we're going to work through 4 stages. The first stage, as you can see here, is preparing data for fine-tuning and evaluation. The second stage, customizing the model with LoRA fine-tuning. The third stage, evaluating the accuracy of the customized model. And finally, the fourth stage, adding some guardrails to make sure that our LLM exhibits safe behavior. For this tutorial, there are a few prerequisites. The first is that we do need to make sure our NeMo microservices are running. We can do this by following this link to our deployment guide. Basically, all you need to do is run the microservices through the parent Helm chart. The parent Helm chart simplifies setup, providing all necessary microservices conveniently in one step to help streamline our development workflow. For the demo today, we're going to need to, after setting up our actual NeMo microservices, add one additional item, which is going to be deploying our Llama 3.2 1B instruct NIM. This NIM can be deployed with this simple command. All this is going to do is make sure that we have the model we'd like to actually work with deployed in our microservice environment. Now, NIM is our inference microservice, which is easy to use, basically designed for secure, reliable deployment of high-performance AI models, across the cloud, data centers, workstations, whatever you're using. So that's why we're selecting the NIM. Before moving on to the rest of the tutorial, you'll need to make sure that you set up your config.py. These values are going to be provided to you during the setup process. Your Hugging Face token will need to be something that you provide from your Hugging Face account. Optionally, you can use your WANDB API key, and the rest of these I recommend leaving as their defaults. In order to set up our data, first we need to make sure that we have the actual data downloaded, and then we're going to prepare it for both customization and evaluation. After some boilerplate in the notebook, you're going to be asked to go ahead and provide your Hugging Face token. Now, this token will need to be associated with an account that does have access to this particular data set. It's just a simple form submission on the Hugging Face website, but once you have that token, you're free to download this data set, which is going to be in this following format. Taking a little bit of a look at the XLAM dataset, we can see that the dataset is comprised of a number of rows, where each row is going to be associated with a query, some answers, and some tools. The idea here is that the XLAM dataset is going to provide our LLM with a query, as well as some potential tools, and then the responsibility of the LLM is going to be to generate the correct tool call given the list of tools in query. So in this case, our answers result is the ground truth that we're going to use to determine whether or not our LLM correctly identified which tool to use and when. We need to do a little bit of work to make sure this format is compatible with both our NeMo Customizer microservice as well as our NeMo Evaluator microservice, which is what we're going to look at next. To prepare the data for customization is fairly straightforward. What we're going to do is we're just going to make sure that we've provided the data in this following format. Now, this is specific to Customizer in order to make sure that it runs well with this job. It's going to be important it's in this format, and so what we've done is we've gone ahead and we've provided you with an actual helper function to help you get this done. Now, the helper function has a lot of code, but don't worry about it. All you need to do is run this convert example, and then we're going to run it across the entire data set. Once you've done that, your data is now in a format that's ready for NeMo Customizer microservice. Before we move to the next step, however, we're going to go ahead and split this data set so that we have our classic train, validation, and test. Next, we're going to prepare some data so that it's compatible with the evaluator microservice, which we'll get to in just a second. As you can see, we have the same kind of thing here, where we need to make sure that our data is in a very specific format. What we're going to do is use, again, the helper function to help us get into this format. You'll notice that all you have to do, once again, is run the convert dataset, and that's going to help you get that data into the desired format. Now that we have data in our desired format, we're good to move on to our actual fine-tuning and then evaluation. After we've done that, we're going to implement some guardrails, and then we'll have seen the whole end-to-end example. This whole time, we've actually been using just Python, and we're about to get into those microservices in the next step. For customization, it's pretty straightforward. We just have to do some checks. Then we're going to go ahead and we're going to upload our data to NeMo Data Store. We're going to provide the configuration needed to do LoRA customization through NeMo Customizer. And then we're just going to do some inference gut checks to make sure things are working. The first thing we're going to set up is a namespace for data store and entity store microservices, which will be spun up as part of the parent Helm chart that you ran in order to start this tutorial. Now you'll notice that what we're going to do is create a namespace for both our data store and our entity store so that we can keep track of things a little bit easier. In this next step, what we're going to do is upload our data to the NeMo data store. So what we're going to do is we're going to create a repository ID. Then we're going to go ahead and use the Hugging Face API to create our repo. Once we've done that, we're going to upload our actual dataset files to NeMo Data Store. And then finally, we're going to register that dataset with the NeMo Entity Store so that it can be seen by our NeMo Customizer microservice. Starting the training job is an incredibly straightforward process. All you have to do is submit it to the actual job's endpoint. You'll notice here that we've provided this code snippet. This is the whole code to get the training job started through NeMo Customizer microservice. You'll notice that what we need to provide is a name for the thing that we're going to customize. We need to provide an output, including namespace, for our model. We're also going to point at our base model. This is the model we're starting with. We're going to provide a way to get to our data set, and then we're going to set up the actual hyperparameters for our training run. You'll notice that we're going to do supervised fine-tuning with our LoRA. We're going to train for 2 epochs with a batch size of 16. We're going to go ahead and use a very small learning rate, and we're going to set up some LoRA configs here as well. NeMo Customizer leverages efficient fine-tuning techniques such as LoRA for SFT, optimizing large language models for various use cases. The big idea here is that it's this API call to get things fired off, and that's it. All we have to do now is run some code to verify that our endpoint is up and active, and we're going to just check back every so often. You could put this in a loop until we see that our status has been completed. Once the status is completed, we're ready to do that gut check to make sure everything worked out. As you can see, we take a sample of our data, and we're going to go ahead and send that to the newly customized NIM. In the newly customized NIM, you see that the response we get is a function that has the argument city, New York City, zip code by city is the function name. And you'll see that in the ground truth, we have function zip code by city, and we call it with city on New York City, exactly what we'd expect. Now we're going to go ahead and take note of our custom model name in order to move to the next step, which is going to leverage the evaluator microservice. The evaluation microservice is, again, very straightforward. Basically, what we're going to do is we're going to go ahead and establish a baseline accuracy. So we're going to evaluate the base model, and then we're going to evaluate our LoRA customized model. What this means is that we're going to have both the accuracy from our original model and then the improvement that we got from that customization process. There are 2 main entities that we need to care about with NeMo evaluation microservice. The first is an evaluation config option. Basically what this is it's how we wish to evaluate the model or system, in fact, that we want to evaluate. You'll notice that we're going to use a custom eval type called custom tool calling. It's going to use a custom data set, which is the data set we configured earlier in this process when we did our data preparation. And then we're going to look for exactly this template in order to evaluate, did we get the correct tools and the correct function? The next component of our evaluation job is going to be our target. So if our config is how we're going to evaluate, target is what we're going to evaluate. In this case, you can see we're going to point our target at our base model. This is the NIM that we set up, again, when we're doing the initial setup steps here. And the idea is we just want to see how well does this NIM do on its own before the customization. So all that's left to do is fire off this job, which will kick off our evaluation job. We're going to go ahead and just wait for our job using this helper function that you see here. And once we're done waiting for 235 seconds, we're good to go ahead and see how it did. It did not so good, right? So you can see here that we get some stats back, and this tells us that, in fact, it did pretty bad on this task. Function name accuracy was quite low, and function name and args accuracy was even lower. So let's go ahead and see what the customized model can do. You'll notice that for the customized model, we don't have to recreate that config, right? Since that config was created initially, we can now just swap our target since we're trying to evaluate exactly the same way. The how hasn't changed for our evaluation. It's just the what. So we point now at our customized model, and again, we kick off the job and we wait. 230 seconds later, we get a much better response. Function name accuracy is now up to 0.92, and our function name and args accuracy is now up to 0.72, a massive increase over the baseline model. So far, we've been able to customize our model. Then we've been able to evaluate that, in fact, it's much better. All that's left to do is apply some guardrails so that we can make sure this model is used in a safe and effective manner. For guardrails, again, very few steps. We're going to add the guardrails configuration, and then we're going to evaluate the safety guardrails. This is going to be by eyeball. So we're just going to make sure that it's working the way that we'd expect it to work. What we're going to do is we're actually going to use the content safety NIM. Now, the content safety NIM is going to help us ensure that our interactions remain safe and compliant. The way that it does this is by having a NIM essentially act as a guardrail, right? It verifies that user input, making sure that nothing, inappropriate squeaks through when customers are using this particular service that you're offering. With that particular content safety NIM, we're going to go ahead and add the guardrails configuration to the microservice. Again, this is done pretty straightforwardly. It's just a simple API call. We're going to go ahead and apply it for this tool calling input. What we're going to do is add a rail, and it's going to be an input that checks the content safety check, right? So just to make sure that incoming content is safe. The prompt here is basically just to see, check if there is unsafe content in the user or agent messages in the below conversation in accordance with our safety policy with the below categories. Provide a safe or unsafe rating, and you can see it goes on to describe in detail what is happening here. But this is the idea. It's just going to check and make sure that input is safe. If it's safe, it's going to let it through. If it's not safe, it won't let it through. And finally, we're going to set up some safe and unsafe messages, and we're just going to see how this works, right? So let's scroll down and check it out. We have this class that helps us implement the actual guardrail with tool calling. Once we've got this set up, we can go ahead and just activate this with our NIM. And you can see here that for this guardrails off situation, we can pass in our unsafe message and get a response, right? This is not ideal. So let's turn our guardrails on and see that if we pass in our unsafe message, we're going to go ahead and get the response that it was blocked due to that safety check. Then with our user query that's safe, this is our safe message. If we run this with guardrails on, you can see that we get the actual response the way that we would hope to. So in this tutorial, we've customized a model specifically for function calling using the XLAM dataset, verified its accuracy using NeMo Evaluator, safeguarded model deployment with NeMo guardrails, and used the whole NVIDIA NeMo microservices pipeline to streamline this workflow with simple APIs, making it nice and straightforward for development and deployment of precise function calling AI applications. To learn more about NVIDIA NeMo microservices and try this tutorial, visit the links provided in the description.